Welcome to my new YouTube channel, Billy's Educator Lab. In this YouTube channel, I would like to discuss the topics of computer science engineering. In this YouTube channel, I will cover the topics of coding and as well as the subjects of computer science. Coming to this first video session, which is on computer organization and architecture. In this session, we will discuss about the first chapter of computer organization and architecture. The first chapter of computer organization and architecture was register transfer language and micro operations and basic computer organization and design. In this first session, we will cover the introduction part and the bus transfers in this first video session. Coming to the introduction part of register transfer and micro operations. What is a register? Register is a storage unit inside the CPU which stores the binary information. And these registers are denoted by the capital letters and the numericals. And there are various types of registers, which are instruction registers, program counter, address registers, temporary registers, data registers, accumulators, output registers, input registers, and there are various types of registers, each of different bits. There are 5 bits. There are 5 types of bits in the registers, which are 8-bit registers, 16-bit registers, 32-bit registers, and 64-bit registers. And in future we will get registers, 8-bit registers. And in this video session, we will discuss about a 16-bit register. In the 16-bit register, there are 12 bits which holds the address of the register, and remaining 3 bits which holds the opcode of that register, and 1 bit which is the I bit, which says that the instruction is either a direct instruction or an indirect instruction. Coming to the micro operations, the operation executed on the data stored in the registers are called as the micro operations, and it is an elementary operation performed on information stored in one or more registers. Here the operation which will be performed on one or more registers is known as the micro operation. When the micro operation is executed on the data stored in the register, there will be some changes inside the register, and the new data will be attested to the register, and or some data will be erased from the register, and some data will be shifted to another register or cleared. Some of the examples of the micro operations are shift micro operations, count, clear, load, arithmetic micro operations, and logical micro operations, etc. And coming to the next one is the register transfer. Before discussing the register transfer language, we will discuss about register transfer. A register transfer is nothing but a hardware logic circuit that performed a stated micro operation and transfer the result of the operation to same or another register. Here, when a micro operation is occurred, then the data has to be transferred. So how the data is to be transferred? By using the register transfer, the data will be transferred from one register to the another register or to the same register. So how this register transfer will be occurred? By using register transfer language, we will do the register transfer, and this register transfer was occurred by the micro operations. Everything is interlinked in the CPU. Coming to the register transfer language, the symbolic notation used to describe the micro operations and the sequence of the micro operations is called as the register transfer language. Here the symbolic notation, here we during the transferring from one register to another register, here this arrow mark shows the data of R2 register is transferred to the R1 register. Here this is the symbolic notation, which is nothing but the register transfer language, symbolic form of the micro operation sequences, which shows the sequence of the micro operations. An example for register transfer. Here R1 and R2 are the 2 registers holding some data. The content of R1 register is transferred to the R2 register. R1 1100 and R2 is same as R1 1100. the content which is in R1 was directly transferred to R2 by bit data transfer. Here, what is bit by bit data transfer? Here 0 first bit. Here by what is the content in the first bit of the to the first bit of the second register. Similarly, the remaining bits also transfer the bit by bit data transfer by using the bit by bit data transfer. If we consider an R3 register same as R1 1100, the content of R1 is transferred to the R3. So when we transferring the R1 data to R3 register, it is very complex to draw a line between R1 and R2 and R3. So to provide the solution for this, we use bus transfers, in which we will discuss more examples on this register transfer, how the data is transferred between the multiple registers in the topic. Multiple registers, it is very difficult to transfer the data by bit. So to overcome that problem, we use bus transfer. What is a bus transfer? A digital system composed of many registers and paths must be provided to transfer the information from one register to the another registers. Here there is one register and its path is shown, and there is another register, its path is also shown, and here there is another register, its path is also shown. Here it is a digital system composed of many registers and the paths. Here there are different paths which are used to transfer the information from one register to the another register. Okay, a bus structure on the other hand is more efficient for transferring the information between registers in a multi-register configuration. Here we consider a 4-bit bus transfer. In this 4-bit bus transfer, there are 4 multiple registers. Here the data is transferred from one register to the another registers. By using the selection lines, we can transfer the data from one register to the another register. Let us discuss the 4-bit bus transfer example. Here in this 4-bit bus transfer, there are 2 selection lines, 4 multiplexers of size 4x1. 4x1 is nothing but 4 input lines and 1 output line, and we consider 4 registers of size 4 bits. I will say at the end of the session why we use 4x1 size of multiplexers, why we didn't use 8x1 size of multiplexers in this 4-bit bus transfer. Here when we consider A3 of register A is connected to the first MUX3 and B3 is connected to MUX3, register C 4th bit is connected to the MUX3, and here register D to the connected to the 3rd bit of MUX3. Here the data of register A, register B, register C, register D is sharing towards the multiplexer, 3rd multiplexer. So in order to transfer the data from one register to another register, here we are transferring the data of 4 registers into a single multiplexer, which provides a common bus output. Here there are 4 registers but a single output, which is a common bus output. How to select the registers? If we want to transfer the data of register A and we want to get the only output of register A, then we used to select 0 0 for getting the output as A. If we select 0 1, then the output will be B. When we select 1 0, then the output will be C register, and when we select 1 1, then the output will be D register. Here in this 4x1 multiplexer, each bit of each register is connected to the different multiplexers of size 4x1. Okay, k register of n bits each produce n line common bus. Here how many registers? 1, 2, 3, 4. There are 4 registers, so how many outputs should we have? 1, 2, 3, 4. So 4 line common bus is used in this 4 bit bus transfer. So a k register of n bits, and here how many bits? There are 4 bits. So how many outputs should be there? 4 outputs should be there. So by using this bus transfer, we will transfer the data of different registers at the same time, and it is very easy to provide the output of different registers inside the computer. Discuss the example. If there are 8 registers of bit 16 bits, and how many multiplexers we require? The number of multiplexers are equals to the number of register bits. Here we consider 16-bit register, so number of multiplexers are equals to 16. So what should be the size? The size should be equals to the number of registers we take, 8 by 1, in which 8 inputs are taken and 1 output. Number of selection lines are equals to 3. Since we consider the 8 registers, which is 2 to the power of 3, so number of selection lines are 3. Okay, thank you for watching my video, and please subscribe to my channel for further updates, and please comment if you have any doubts, and please share to this to your friends. Thank you everyone.